This is our first HSC topic, and it's called functions, and its outcome is MAF2. You will get a copy of this. So what we've got here is, we're just going to look at the dot points within this topic. So we are applying transformations to sketch functions of the form. Actually, we'll read y equals a constant times a function. You've got another number here, a sideways shift and an up and down shift. But we're going to be looking at these all separately. So we've got a stretch. Here's another one. We've got a sideways shift and an up and down shift. But the types of functions we're looking at for the HSC course, we've already actually done some of these, some of them in year 11. Is a polynomial, which is, polynomial. Reciprocal, which is 1 over x types. Reciprocal functions are like 1 over x. They're hyperbolas. Absolute value functions, v's. Remember we did some of those last year. Exponential functions we did towards the end of last year. And logarithmic functions we also did towards the end of last year. Where a, b, c, and k are constant. So I know that looks a little daunting, but if we look here, here's the first. This is what we're doing today. So we're examining translations and graphs of just a function being shifted where? Function of x plus c. What does that mean? Shifted up or down? Yep. And y equals function of x plus b. Left or right. That's all we're doing today. The reason we're doing that today is you've already done it. So it's revision. This is in exercise 15.1 of your new textbook. Okay, tomorrow we're going to be looking at examining dilations. When you hear the word dilate, what do you think of? An example might be when they put eye drops in your eye when they do eye tests. It makes your pupils dilate and they get really, really big. Okay? And then, so a dilation is like a stretch. Okay? Dilations of the graph. Now have a look at this. K is a constant. So where the constant is in front of the function, that's what we're doing tomorrow. And where the constant is next to the x. See how we've got, so this might be function of 2x or 3x or half x. We're doing those tomorrow, exercise 15.2. And recognizing the order in which those transformations are applied is important. 15.2, 15.3, 15.4 from your textbook, these dot points here. Okay, so that's what we're doing over the next few days. Okay. Exercise 15.1. So remember, like I said, with that first dot point, looking at function of x plus c, which is a shift up and down, and function of bracket x plus b, which is a sideways shift. If this is the graph y equals x squared, this is x plus 2 squared shifted 2 units to the left. Of course, you would put what the y-intercept here is. Whenever you're sketching a function, we want 2 points that we know. And I can see 2 points there and there. Okay? And y equals x squared plus 2, shifted up 2. Just having a look here. So this is y equals x squared. That's y equals function of x. You can see that this is the sideways shift. That's just your x plus b squared. And that's just your function of x plus c. Okay? Now, as we said, move 2 units to the left, and this one is moved 2 units upwards. We already know this from prelim. Again, similar thing for cubic graph. Remember, we have to also do some other types of graphs. So we've got y equals x cubed. This was preliminary. This is shifted 2 units to the right, preliminary. Same graph, shifted 2 units to the right. This is x cubed, shifted 2 units down. Okay? We looked at this in prelim. Okay? What we also looked at last year, and what we were doing a little bit last lesson, was looking at the reciprocal function. This is called the reciprocal function. Y equals 1 on x. You know, quadrants 1 and 3. You know this. This is shifted 2 units. We were just drawing these. Shifted 2 units to the right. Again, quadrants 1 and 3. You know how to do these from last year. And this is y equals 1 on x, shifted 2 units down. So just take that graph and shift it 2 units down. We did these last in year 11. Okay? So that is revision. Function of x plus b is just the graph function of x. Moved b units to the left if b happened to be positive. All right? And function of x plus c, it's just moved c units upwards. But if c was negative, it would be moved downwards. Okay, now, what I do want you to do, well, you will get this. You will get this. Let's look at these. I know that you don't know what these graphs are, but you could just do it by plotting points. Okay? Look, I'll tell you where it does come from is it's like a parabola, you know, but it's sideways. Right? It's like a parabola, but it's half a parabola. I'll tell you why. If I take the graph, the first one, look, y equals square root of x, and if I square both sides, what do I get? Square both sides. Now, you're used to y equals x squared for a parabola, aren't you? Because this is x equals y squared, your x-axis becomes your y-axis, and you just turn it around. Are we okay? All right. So what you've got to think is, I know y equals x squared, but this is the opposite. This is x is y squared, so it's just a sideways parabola. But because it's not the whole thing, it's been square rooted. So what we would just do at this stage is just to plot some points. When x is 0, having a look, what's y? When x is 2, y is the square root of 2. A really nice point would be to plot what, do you think? When? Yeah, when x is 4, y is 2. That would be a really good point to plot. So if you were trying to sketch this, you'd go when x is 0, y is 0. When x is 2, you get square root of 2. But when x is 4, you get 2. Square root of 2 is about 1 point something, I don't know. 1.1 something. But that's what that looks like. So if you know what, so all we want to know is what this one looks like. So isn't this just shifted 2 units to the, no, left. So this is y equals root x shifted 2 units to the left. Actually, this is the one that I'd like you to write down. Do you have books? Or you can just wait and I'll copy this. So this is y equals the square root of x shifted 2 units to the left. So that moves 2 units. So that means that the point when x is 2, you get 2. So that's a nice point. When x is 2, square root of 4 is 2. And if you look at y equals the square root of x plus 2, isn't that just y equals the square root of x shifted up 2 units? So you just take that graph and you shift it up 2 units. Tell me when x is 4 what you would get. You would get 4. When x is 4, you get y is 4. Yeah. Okay? So that is just y equals the square root of x shifted up 2 units. And I'm off screen. So you get 4, 4. Okay? So that's new. That type of graph is new. Okay? It's -1 or -2 or -4. Because you can't square root a negative. Okay? But here I can do negative values because what's under the square root ends up being, when x is -2, that's allowed. Because -2 plus 2 is 0. That's why you get when x is -2, y is 0. Okay? But again, anytime you sketch a curve, we want 2 points sketched on that curve. So I need -2, 0, and I need 2, 2 here. All good? And here I need this point, and I need that point. Otherwise, we're not going to know what the curve is. Or you could have put 2, but you'd have to put 2, comma, root 2 plus 2. Root 2 plus 2. I'd just go with the 4, 4. It's nice and easy. Okay? Exercise, you have transformations of sine curves. Don't worry about this. We're doing this in the next topic, trig functions. Do not worry about sine, cos, tan. Please just ignore sine, cos, tan in these exercises. Now wait, wait, wait. You do not, question 1, you know how to do. 1A, you know how to do, yes or no? If I ask you to do that tonight, yes? Question 1C, you know how to do? You know how to do this one now. All right, so you'll do that. Do not do 1D yet. We're doing that in 2 weeks' time. Because for D, we'll be looking at trig functions, sketching those, one whole topic. It's a separate topic. The reason is that is chapter 12 and this is chapter 15, so they assume in the textbook we've done it, but we haven't. So do not do, you'll be doing questions 1, A, B, C. Question 2, I'm going to do 1 or 2 of these with you now. Question 2, we did questions like question 2A last term, and we did questions like 2C last term. So you're going to do those for practice. I want to do B or D. You know, y equals ln x, do you remember that? But ln x minus e, it's shifted how many units where? E units across to the right and E units down. I think I want to do this one, and we're going to do D as well. So you're going to do A and C for homework. Here you're going to do A, B, and C. I'm going to do these now, okay, because they can be a bit tricky. Not that they're tricky, it's just the labeling. I want you to label them properly. The other things that I'm going to do with you now, we're not doing question 3 because we're doing that in another chapter. But I really do want to do question 4, but not B. We're not doing B. That looks very much like extension to me. Okay, so I want to do 4A and B now. So that's what I'm going to, A and C, sorry. I want to do questions 4A and C, and I want to do questions 2B and D with you. You are doing the others for homework, okay? And we're not doing 1D, we're not doing 3, and we're not doing 4B. Oh, it's not focused. It will in a minute. You're also going to do question 5 for homework, okay? From exercise 15.1. 15.2 is below. We're doing that tomorrow. So 15.1, you'll be doing question 5 as well. It's just multiple choice. These are slightly different to what we did last year. The others are very similar. We're going to sketch y equals ln x minus e, and ln x minus e. So doing a Cartesian plane. All right, let's choose some values. Be careful with the values you choose. We only need 2 on each graph. What's your first value? ln what? And don't go putting in all the figures. So I'm going to put 1. All right, what's ln 1? No. Do it on your calc. ln 1 is 0. What's ln e? So here, I'm doing a little table of values. X, Y. ln 1 is 0. ln e is, anyone know ln e? Log to the base e of e. Okay, grab your calculators, girls, if you're not sure. ln e is 1. So ln of e, ln means log to the base e. So ln e is log to the base e of e. Remember that rule? That equals 1. So do ln 1 first. Make sure you get 0. ln e is 1. That's why I chose it. Now, where's e roughly? About 2.7, so it's about here. So ln e is 1. So I'm just going to go like this. 1, 2, 3, but I know e is about there. It goes like this. So I need to label the point. That is E1. This is, I can see, is 1, 0. What happens to the rest of the graph? Anyone? Grab your calculator. Do ln of 0.1. It's down here. If you're not sure what happens to the graph, do ln of a half, ln of 0.1. ln, everyone grab your calculators and do it. So it's down here. That's an asymptote. That's what the ln curve looks like. That is an asymptote, girls. Make sure that does not touch or cut or whatever. That's the ln graph, and e to the x is up there. Remember those? All right, so that's y equals ln x. Do that one in black. All right, now I want to sketch ln x minus e. So it's shifted how many units? This is shifted, no, this one's this one, x minus e. E units to the right. Think of some nice things to substitute. So what did I put? 0.1. ln of 0.1 was what? Negative. ln of 0.1 was what? Negative 2 something? 2 point whatever. Right. All right. Let's think of some nice values to substitute for y equals ln x minus e. So I've got x and y. You know what I'd love to substitute is e. E would be great. Oh, yeah, you can't do that. Good. Very good. So you can't do ln e. You're right. Undefined. No good. 2e is good, because that gives me 2e minus e is e, which is, what's ln e? 1. How am I going to get, all right, okay. Isn't y equals ln x minus e is the graph of y equals ln x shifted e units to the right. So all you do, look at your graph, and every point that you can see, move it e units to the right. I know this is a little bit painful. So girls, if this is 1, I need to move this point 2 units to the right. 1 plus e is 1 plus e. 1 plus e is 1 plus e. So what I'm going to do, I'm going to put a few more dashes. What does 1 plus e approximately equal? 2.7, 3.7. You know how e is 2.7? 1 plus e is about 3.7, so it's roughly here. So this is approximately 1 plus e. So when x is 1 plus e, what does y equal? All right, I've got to make this bigger. Sorry. So when x is 1 plus e, look, 1 plus e minus e is ln 1 is 0. So here, there. So girls, remember I'm moving all of these 1 unit, sorry, not 1 unit, e units across. So that point is now here. Where's my asymptote going to be? This is, I think it's here. Isn't it 1 unit back from there? Look how I cut here at 1 and my asymptote's at 0. So what's 1 unit back? Oh, we know where the asymptote is. You can't have ln e. So you can't have x is e. So my asymptote for the next curve is at e. Do you see? Because when I substituted x is e, I got undefined. ln 0 is undefined. So I've got the asymptote that looks like this. See? My asymptote was at 0 and now it's e units across. My x-intercept was at 1 and now my new x-intercept is e units up from 1, 1 plus e. This is the point E1. What's my new point? We've done it. Anyone? E1. E units across from there is, we've done it up here, 2E1. So look, if you move E units across, instead of going E1, you go 2E1. So you're trying to move, I know this is really tricky, all right? It's tricky because you're dealing with E. What's 2e? 2 times 2 about 5.4-ish. 5.5, roughly. So that's 5, that's 6. It's roughly in here somewhere. So this is, oh dear. Here. So you've got these, so everything has been moved across E units. So we've got asymptote at 0, now asymptote's at e. This will cut through the x-axis at 1, now it cuts through at 1 plus e. Add e to everything. This is the point E1, add e across, because it's shifting across. This new point is 2E1. See how e's been added on to every point, shifted across? I know it's tricky, girls. It is. So this is my curve y equals ln x minus e. Okay, now, in another color, we're going to do y equals ln x minus e. So, oh dear, I don't think I'm going to fit it. I'll just do another graph. So, I'm just going to draw the original one in there. So I've got E1 and 1. So I'm coming down to the next graph. Can I move from there or no? Yes? No? You sure? All right, here's my first graph, y equals ln x. Now I want to do, that's what I had. It cuts at 1, it cuts at E1. Now I want to do y equals ln x minus e. So my table of values, All right, just do your same x values. When x is 1, what do you get? So I had 1. Don't I just move down e from there? This is the point 1, 0. What is the new point? Yeah, e units down, so it'll be at negative e. This is now 1, negative e. Because, look, this is 1, 0. Then I go 1, shift this point down 2 e units. This is the point 1 across, e units down. So I'm shifting down e units. So when x is 1, look, when I put x is 1 here, what's ln 1? 0 minus e. So when x is 1, y is negative e. So that's the point 1, negative e. Yeah? What about when x is e? What do you get? What's ln e? So you get 1 minus e. So these are my points. That'll do. In other words, you're just moving e units down from here. This is E1. So you've got to drop down. So it's just, look, it's going to be the same shape. So just do the same shape, and this will be E, comma, 1 minus e. Because isn't it e units down from the 1? You sure? So look, girls, I've got 1. Take e away from that value. 1 minus e. I've got E1. Oh, sorry, I'm so sorry. Saying the wrong thing. I'm at 0. E units down is negative e. It's 1, comma, negative e. So this is the point 1, 0. I'm so sorry, girls. Keep saying the wrong thing. 1, 0. Now it's 1, negative e. This point was moved e units down from 0. Yeah. Yeah. Right, I've got E1. I have to move. Look, it's best just to do the table of values. What do you think? Do a table of values using the same x values. So when x is e, you get ln e is 1. 1 minus e is the new value. So that's 1. That's E1. It's e units down from there. So that will be the new curve. Shifted down e units. Y equals ln x minus e. On x squared, y equals x minus 1 squared, y equals 1 on x squared minus 1. The only one you have to know how to sketch is the first one, y. Because once you can sketch this, what do you do to this to get that? Shift it 1 unit to the right. And if you know how to sketch the first one, what do? You shift, that's it. So you only have to know how to sketch that. Now, we've never done anything like that. So let's just substitute some values, x and y. Negative 2, negative 1, 0, you're going to see what happens there. 1, 2, we start with that. I think I'll have to do a few more values. Let's go. When x is negative 2, what do you get? Negative 2 squared? Good. So when x is negative 2, we get 4. It is 1 on 4. Very good. Negative 2 is positive 1/4. Good. Negative 1. 1. Very good. All right. Give me another value to do. 1/2. What do you get? 1 divided by 1/4 is 4. All right. I think we can see what's happening. So I've got 1, 1, and I've got 1/2, 4. X can't equal 0. We good with that? Undefined. All right. What about when x is, do the same on the other side. 2, 1, and we will do 1/2. When x is 1, what do you get? Well, it'll be the same as negative 1 because it's squared. When x is 2, 1/4. 2, 1/4, 1, 1. What do you think is going to happen now? What about, oh, that was positive 1/2. That was negative 1/2. Sorry. Positive 1/2, same thing. 4. That was negative 1/2, obviously. Got it? What am I doing? Huh. There. I keep putting positives where they're negatives. Look, if you sketch, this is what it looks like. Here, I've got 1/2, 4. I've got 1, 1. This was negative 1, 1. Negative 1/2, 4. That's what it looks like. Oh, it's a hyperbola in the positive and the negative quadrant, but not down there. Why is it never not in the positive and negative quadrant, in quadrants 1 and 2? Why can't I get values down here? Because y can't be negative, because you've got x squared. So 1 divided by a positive number will always end up here. Yeah. So when x is 1, you get the same as if x is negative 1. And when x is 2, I got the same answer when x was negative 2. So it's a hyperbola, but above the x-axis with no negative values. So now all you've got to do you think you know what to do to shift that? Shift it. So you'll have the asymptote now, instead of here where the asymptote's there, where will it be next? On the 1. And then what are you going to do with this whole thing? Shift it, lift the whole thing down for this one. So this is 1 unit to the right, and this is 1 unit down. Can you do those yourself? All right, so you'll finish those off. And one more I want to do. So you can finish off B and like those two. And there's one more I need to do with you that you haven't seen before. For C, y equals the square root of x squared. All right, I know you haven't seen it, but we're just going to do some values. It actually is a graph you've seen, but you don't know that you've seen it. No. You don't, it's, no. All right, let's do -2, -1, 0, no, and 2. Okay. Tell me what happens to a square root and a squared. They cancel, but you can't ever get a negative value here. So it's going to be something you know. You'll recognize it in a minute. Let's just do when x is 2. So what have you got? When x is 2, 2 squared is, see how the squared is underneath the square root sign? You have to do the squared first, because that's exactly how it's written. 2 squared is 4. What's the square root of 4? All right, 1, when x is 1. 1 squared is 1. The square root of 1 is? 0 squared is 0. The square root of 0. All right, good. Now you have to do the squared first. -1 squared is? The square root of 1 is? And -2 squared is 4. The square root of 4? You'll know it. 1, 1, 2, 2, 2. -1, 1. Yeah, it is. And it's actually the definition for an absolute value, which we do in extension 1. That's what it is. So the definition, so that means that y equals the square root of x squared is the same as the absolute value function. Look. So how would you know? You wouldn't know unless you sketched it. Okay, so I've got that now. Y equals it. Now be careful. Look at the question. X has to be squared before you square root it. Why? Because you can't do the square root of -2 and you can't do the square root of -1 first. So it specifically has to be written like that. Now, let's look at the shifting. So now we have to draw y equals. So also draw y equals the square root of x plus 2 squared. That is that graph with what? Yeah. So I'm just going to write this is y equals the square root of x squared shifted 2 units to the left. That's easy enough to draw, isn't it? Go. Shift 2 units to the left. I want you to shift each piece 2 units to the left. So let's start with the V. Where would that go to? Good. Where would this 2, 2 go to? There. Yeah. So that would move over to there. That would move to there. And this would move over. So guys, it would look like this. So this would be 2 there. That would be -2. And this would be the point, -4, 2. Look, you could just substitute values. but we want to do it with transformations, all right? So this is y equals the square root of x plus 2 all squared. And then the last one we're going to look at is, are we good with that? So if you know your basic function, and if it's a function you don't know, just substitute some values, all right? So I know you haven't seen 1 on x squared and you haven't seen that one, but it's actually just the absolute value function. And the last one we want to do is y equals the square root of x squared plus 2. Isn't that just? Can I just do it up there? It's just this one shifted up 2. Oh, whatever, I'll just do it here. It's just shifted up 2. Like that. You need to put some more points in. That's not enough. So, which other points do you want to put? Just do when x is 1, what's y? And when x is negative 1. 1 is, yep, 3, and negative 1, 3. And that's y equals the square root of x squared plus 2. Okay? So once you've got your basic graph, I know some of those are different. So the syllabus does say that you have to do exponential, logarithmic, which you're practicing for homework. Absolute value we've just done. There is a polynomial as well. One sec.